Hello, my name is Geneva Litz. I will be talking about my project exploring the relationship between BMI and brain activity during the Stroop task in a sample of adults with overweight or obesity. Obesity is a global health concern. The current prevalence of obesity is about 43% in US adults, and over 70% of adults are classified as either overweight or obese according to BMI. Obesity is not only an issue for a person's bodily health, but also executive functioning, including inhibitory control. For example, obesity is associated with slower response times on inhibitory control paradigms like the Stroop task. It is also associated with reduced activity in brain regions important for inhibitory control during these tasks. That being said, a majority of obesity research has compared individuals with obesity to their healthy weight peers. Therefore, there is little research examining associations between BMI and brain activity within an overweight and obese sample. In this study, we wanted to determine if BMI is related to Stroop task performance and brain activity in individuals with overweight or obesity. I hypothesized that higher BMI would be associated with worse performance on the Stroop task, as well as lower levels of activation during task completion. We recruited 124 sedentary adults that were classified as either overweight or obese for a weight loss intervention. The participants were, as you can see in the demographics table, middle-aged, obese, and college educated. Our participants underwent a functional MRI scan while completing the Stroop task. The resulting images were analyzed using a whole brain analytical approach in FSL. We controlled for sex, creating a contrast of interest based on the congruent and incongruent conditions of the Stroop task. The Stroop task is a classic test of inhibitory control. During the task, you are asked to indicate the color of the text that is written on the screen, regardless of the word that is written. In the congruent condition, the word presented matches the color of the text. For example, the word red printed in red ink. In the incongruent condition, the word presented does not match the color of the text. For example, the word green in blue ink. Since our participants were young and performed very well, we used reaction time as a measure of task performance. Using reaction time from the incongruent and congruent conditions, we calculated the Stroop effect, which is a measure of interference that reflects inhibitory control. We found that higher BMI was associated with reduced differences in bold activation in the right dorsolateral prefrontal cortex, left medial temporal gyrus, and the bilateral precuneus. These differences were driven by higher activation during the congruent condition of the task. Activity in the prefrontal cortex and precuneus were also found to be associated with the Stroop effect. These regions have been identified as important for inhibitory control and successful completion of the Stroop task. BMI on its own was not related to task performance. To conclude, in this study, we found reduced differences in activation between the incongruent and congruent task conditions. This was due to increased activity during the congruent condition. This suggests that those with a higher BMI expend more neural resources on the easier task condition. Activation is illuminated as a possible mechanism for better task performance. This is supported by the lack of a relationship between BMI alone and task performance. While this study cannot speak to the specific pathways at play between BMI and the brain, it does show that BMI may be used to tell us something about the neural processes behind inhibitory control. These results can serve as a foundation for a future study exploring the relationship between BMI and the brain after weight loss. Thank you.